All right, let's focus on powers, finding the inverse of a power. First, we're going to switch our x and our y. Okay, we're going to get the part that's raised to a power by itself, or the parentheses. Power, or the parentheses, whatever that is in the parentheses, we're going to get that isolated first. Use the radical with the index that matches. Right? So I guess we'll use the number or the power with the index that matches, well, whatever number's in front, right? That's the power we're going to do. Wow, having trouble this morning. Right? So we're going to take the power, raise it, use the power, and we're going to use the radical with the appropriate index. So if it's to the fifth power, we're going to use a fifth root. If it's to the fourth power, you're going to use the fourth root. So if it's even, though, okay, so if it's even, let's make sure we underline this. If the power is even, then we're going to restrict our domain. Then we need a domain restriction. If it's odd, we don't need one, because it will be a one-to-one. So odd functions, as we look down below, we've got one that's to the fifth power. It's going to have a graph that looks something like that, which is going to pass the horizontal, it's going to pass the vertical test. Where the other one is going to be parabola. It passes the vertical, but it will fail the horizontal test. So whenever I have an even power, I'm going to need to restrict the domain. If it's odd, don't worry about it. Okay, so then we're going to get the y by itself, and then we'll change the y to f inverse of x, just like all the others. Okay, so on this first example, I don't need a domain restriction because it has an odd exponent. The exponent is 5, so I don't need a domain restriction. I'm going to change my x's and y's, so x equals 2, y minus 7 to the power of 5 minus 8. We're going to get these parentheses by itself. We're going to add 8 to both sides, then divide 2. So y minus 7 to the power of 5 is equal to x plus 8 over 2. We're going to take the fifth root. Fifth root's important. We put that 5 there of both sides. Make sure the square root comes down, covers that whole fraction. So y minus 7 equals the fifth root of x plus 8 over 2. And we add 7. Now this 7 is going after the root. It does not go inside. All right, so then we can change that y to f inverse. The fifth root of x plus 8 over 2 plus 7. All right, that's your inverse. And I did not need a domain restriction because I was looking at a fifth power. On this next example, though, we do need a domain restriction because we have a fourth power. So just like before, you'd identify the vertex, which is at -6, -4. And we're going to take the positive radical. So again, we're going to do the h value. All x values, the restrictions will be x values that are greater than or equal to -6. All right, there's our domain restriction. For the inverse, we are going to switch our x and y. Isolate that parentheses, or fourth power, by adding 4 to both sides. And then we're going to times both sides by -3. Let's see, then we'll times both sides by a -3, whatever that is, times -3. So we have -3 times x plus 4 is equal to y plus 6 to the fourth. Might just be easier to distribute that -3. So let's see, we've got -3x minus 12 equals y plus 6 to the fourth. All right, we're going to take the fourth root. So y plus 6 is equal to the fourth root, negative 3x minus 12. Then we take away 6, and that 6 goes after the radical. I can't combine it with that 12. That 12 is inside, the 6 is outside. Then we can change it to f inverse of x is equal to the fourth root of negative 3x minus 12, where that radical comes over and covers the 12, and minus 6 at the end, right? Let's see if I can make that just a little neater. F inverse. There we go. So the second example needed a domain restriction because we had an even exponent. So we had a domain restriction on that one because the graph is going to be parabolic and it's not one-to-one. So we restrict it to only the positive or the right half, or to the right, numbers greater than or equal to negative 6. The first example didn't need a domain restriction because it had an odd power. And the graph of odd powers, is, as we've seen before, is already one-to-one. Where with the even power, it's parabolic in shape and is not one-to-one. So we have to have a domain restriction on those even powers, not odd powers.